we're going to be talking about section 3.2 today, which is talking about truth tables and equivalent statements. So we're going to be talking about conjunctions, disjunctions, negations, mathematical statements related to those, truth tables, and we're going to talk about something that's equivalent and also the De Morgan's law again. So with conjunctions, we're talking about, again, using that symbol, the upside down V, and or using the word and. And again, this implies that both of them have to be true. And we talked about that earlier when we were using logic statements with the sets. So here's our truth table for conjunctions. And you'll notice on our truth table that both the P and the Q value must be true for the statement to come up with a true result. If either one of the P or the Q value are false, then you will end up with a false answer. This is extremely important when you're talking about computer programming and you're doing if statements in computer programming. If you're using the word and or the word or in computer programming or using the symbols for those, you have to be very careful to make sure that you're using the correct symbol or the correct word. So for example, if P represents the statement 4 is greater than 1, okay, so 4 is greater than 1 is a true statement. 4 is greater than 1, so that is a true statement. So P is true. Q represents the statement 12 is less than 9. Well, 12 is not less than 9, so that's a false statement. So we have the symbol and between the P and the Q, which means that both statements must be true to end up with a true result. So since P is true but Q is false, your result is false. So then we also have disjunctions, or the use of the word or the use of the symbol V. And in those cases, we're looking for either one has to be true in order for the statement to come out true. So again, and you'll notice in this case, all of the results are true except for the one case where both of them are false. So let's look at it again. So in this case, again, 4 is still greater than 1. So P is a true statement. 12 is less than 9 is still false. 12 is not smaller than 9. So the Q value is false. Our symbol has changed though. We're looking at the word or we're looking at the disjunction between the two. So since P is true and Q is false, since one of the statements is true, our result would be true this time. Okay. And then we have our negation table. So negation again just means the opposite of. So it would be not P. So if P is true, then not P is false. And if P is false, then not P is true. So let's look at this. I have this statement that 4 is greater than 1, which is true. And I have this statement that 12 is less than 9, which is already false. So we've talked about this. This statement is true. In other words, P is a true statement. Q is a false statement. And R is something new. It's a new letter. It represents 0 is less than 1. And 0 is less than 1, so that's a true statement. So anywhere that we are using P, we can replace that with a true. And anywhere that we have a Q, we can replace that with a false. So since I have the tilde in front of the P, or the negation symbol, that means that's not true, which is false. The symbol that we have here is the and symbol, or the conjunction. And then the tilde false means true. And remembering that with the and symbol or with the conjunction symbol, they must both be true, the result of this statement would be false. So then we do the same thing down here. P is true. R is false. That's the 0 less than 1 that we had up above. Q is false. Oh, excuse me. R is true. I looked at the wrong thing there. Okay, R is true. And then P is true also. So because things are inside the parentheses here, we're going to do our negation. So the negation of this is false. And symbol, true. That's in parentheses, so just like order of operations, we're going to do that first. So false and true would be false. Now we're going to do the second part of this. The negation of false is true. Our and symbol again, and true. So again, we're going to do our parentheses now. So true and true is true. So false or true, remember with or, you only have to have one true statement, so that would be a true result. All right, so this is the standard way that a table will look for your truth tables, and you can, depending on what the statement is, if it's an and or an or, you can fill in the appropriate results. So here's what we want to do. We want to construct the truth table for this problem. So basically what we're going to do, I'm going to go ahead and show you the answer and then we'll talk about it. We're going to set up a table with all the possible values. Now our P and our Q will always be the same. It'll always be true, 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 false, false, true, false, false. That will not change as long as you're dealing with just P and Q. The negation of P and the negation of Q should be your next two columns. So the negation of P is the opposite of our P value. So we're looking again, here's our P value, the negation of P is false. Here's our P value, the negation of that is false. The negation of the false is true, the negation of the false is true. So those are related to each other. And then the next column, we're going to do the negation of Q. So the negation of Q is false. The negation of false is true. And here are our negations. And now we're going to use our truth tables to answer the next part. So the symbol that we have here is or, which means one of them must be true. One piece must be true in order for the results of the problem to be true. So here we have two falses, so since neither one of those is true, our answer is false. On this one, since our second one is true, the result is true, and the other two are also true. So now what we're going to do is we're going to combine together and we're going to look at this column and we're going to compare it to this column. And we're wanting to know, again, our symbol that we have here is and, which means they both have to be true in order to be true. So since the second column is false, our result is false. On this one, both of the results are true, so our result is true. On this one of them is false, so since they're not both true, our result is false. And the same thing for the last column. So setting up the truth tables will really help you to answer the questions and not try and do it in a shortcut method or some other shorter method. There's really not much easier way. So what we're trying to figure out here is how many rows will our truth table have in it. So in all of our cases, we had two components, or in most of them, we had a P component and a Q component. So since there were two components, N equals 2. So to figure out how many rows of data we're going to have, it's 2 to the nth power, which is in this case 4. But what if I had a P, a Q, and an R like I did on an earlier example? Then that means n is equal to 3. So I would have 2 to the third possibilities, which would be 8 possible rows of information. So the more values that you put in here, the more complicated your charts can become. All right, so our statements are equivalent if they have the same truth value in every possible situation. So let's look at what we mean by that. So I want to know if these two statements are equivalent, and this is going to lead us to De Morgan's law, the second part of De Morgan's law. So let's look at this truth table. So if I take each of the values and I negate them, this would become false, and this would become false. So if I negated both of them, and then I do my and symbol, that means they both have to be true, so that didn't work. If I negate them both, they both have to be true, so that didn't work. I negate them both. They both have to be true, so that didn't work. I negate them both. They both have to be true, so this one did work. Okay, so now if I go back to my clean slate and I look at it again, this time I want to figure out the result of the disjunction, in other words, using the or symbol, and then I'm going to negate that. So imagine that I've got the or symbol between each of these. And remember, with or, only one has to be true. So this would be a true result. This would be a true result because one of them is true. This would be a true result, and this would be false. And then what I want to do is negate that answer. So the negation of true is false. The negation of true is false. The negation of true is false. And the negation of false is true. So here's this question. Are these two statements equivalent? And the answer would be yes, because every value in the truth table is the same. And that leads us to De Morgan's law. And De Morgan's law says the negation of the conjunction, the negation of the disjunction is the negation of each of the pieces with the conjunction symbol. So you'll notice what happened here is basically the negation symbol almost distributed. And so it distributed to the P, it distributed to the Q, but it also negated the disjunction symbol and caused it to be a conjunction symbol. The second example, it negated the P and the Q, just like we see down here, but it also negated the conjunction symbol and made it into a disjunction symbol. So that's what De Morgan's law is saying to us. Okay, so if we use De Morgan's law on this statement, it says find the negation of each statement by applying De Morgan's law. So basically, again, what I'm saying to you is that we're going to take the three parts to this problem. I made an A, I made a B, and the symbol or, and we're going to negate each of them. So the negation of I made an A is I did not make an A. Negation of I made a B is I did not make a B. And the negation of or is and. On this one, three parts. She won't try, he will succeed, and then the and symbol, or the word and. So the negation of she won't try is she will try. The negation of he will succeed is he will not succeed. And the negation of and is the word or. So our new statements using De Morgan's law is that I didn't make an A and I didn't make a B. The negation of the second symbol is she will try or he won't succeed or he will not succeed. I hope this helps. Just let me know. Keep in touch. Make sure you're keeping up with your work and let me know if you need more help on anything.